Today we're going to solve some equations. We're going to solve some trigonometric equations. This equation has a sine x in it. This equation has a tangent x in it. This equation has a secant x in it. The variable in all of these is x, but we're going to treat the sine x as the variable. We're going to treat the tangent x as the variable. We're not going to isolate the x. We're going to isolate the tangent x, or the secant x. Let's start with number 1. Let's try to isolate the sine x. We can add 1 to both sides. And we can then divide 2 to both sides. And we see that sine x equals 1/2. Now, before I continue, let me point out that all of these trigonometric equations technically have an infinite number of answers. There are an infinite number of angles that have a sine of 1/2. We're going to find all the values in between 0 and 2 pi. So we have a limit on how many answers we have to provide. Well, this task is quite simple, provided you have a unit circle. Let's just look on the unit circle and see where sine is 1/2. Sine is 1/2 right here at pi over 6. And sine is 1/2 over here as well at 5 pi over 6. There are no other places in between 0 and 2 pi where sine is 1/2, so I'm going to say our two answers are pi over 6 and 5 pi over 6. In number 2, I have negative radical 3 times tangent x. Let me isolate the tangent x by dividing both sides by the negative radical 3. And hopefully you can see this negative radical 3 and negative radical 3 will cancel out. And positive 1 divided by negative radical 3 is negative 1 over radical 3. We need to find on the unit circle which angles have a tangent of negative 1 over radical 3. Well, that might be easier if our unit circle had the tangent answers on it as well. There we go. There are all our tangent answers. Of course, it's going to be easier to identify if we rationalize the denominator. We want to find where tangent x equals negative radical 3 over 3. And there should be two places on the unit circle where tangent equals negative radical 3 over 3. Over here it does at 5 pi over 6, and over here it does as well at 11 pi over 6. In number 3, I'll isolate the secant x by dividing both sides by the square root of 2. These square root of 2's cancel out, so secant of x equals 2 over square root of 2. Now, the unit circle has our cosine values, our sine values, and we even added our tangent values, but it doesn't have secant values. Let me rewrite this. If secant of x is 2 over radical 2, then cosine of x is the reciprocal of that. Cosine of x is radical 2 over 2. So let's go look on the unit circle and find where cosine equals positive square root of 2 over 2. It does right here at pi over 4. Over here it's negative radical 2 over 2. Here it's negative radical 2 over 2. Oh, here we go. Here it's positive radical 2 over 2 at 7 pi over 4. There are two places where cosine of x equals positive radical 2 over 2. Pi over 4 and 7 pi over 4. In example 4, I'm going to isolate the cosine x. Let me begin by adding 1 on both sides. And I can then divide 4 on both sides. Recall that cosine squared x really means cosine of x squared. I can undo the squared by square rooting both sides. When I square root this side, it's going to be simply cosine x. And when I square root this side, let us not forget that it's plus and minus. The square root of 1/4 is 1/2. This time we're going to spin around the unit circle and find the angles where cosine is either positive or negative 1/2. Right here, it's positive 1/2 at pi over 3. It's negative 1/2 at 2 pi over 3. It's negative 1/2 again at 4 pi over 3. And it's positive 1/2 at 5 pi over 3. In number 5, I'll isolate the cosecant x. Let me divide each side by 3. And once again, to undo the squaring, I'll square root each side. So cosecant of x equals the square root of 4/3. Let us not forget that it's plus and minus, and the square root of 4/3 would be the square root of 4 over the square root of 3. The square root of 4, of course, is 2. So we can say the square root of 4/3 is plus or minus 2 over radical 3. Now, the unit circle doesn't have cosecant values on it. It has cosine values and sine values. Let's rewrite this. Sine of x is always the reciprocal of cosecant of x. So sine of x could equal plus or minus square root of 3 over 2. Let's go see where sine of x is either positive or negative square root of 3 over 2. Here it's positive square root of 3 over 2 at pi over 3. It's also positive square root of 3 over 2 at 2 pi over 3. And it's negative square root of 3 over 2 in two places, at 4 pi over 3 and at 5 pi over 3. Before we look at number 6, take a look here. When we solve a quadratic equation like x squared minus 4x plus 3, we solve it by factoring. We rewrite it as the product of two linear factors, and then we set the two factors equal to 0. Well, number 6 is already written in this factored form. To solve this, we will just set both of these factors equal to 0. Over here, I'm going to add 1 and divide by 2 on both sides. And here, I'm going to subtract 1 on both sides. So we need to go find where sine of x equals positive 1/2, and we also need to go find where sine of x equals negative 1. Sine of x equals positive 1/2 right here at pi over 6. And it also equals positive 1/2 here at 5 pi over 6. Sine of x equals negative 1 only in one place. Right here, sine is negative 1 at 3 pi over 2. This equation has three answers: pi over 6, 5 pi over 6, and 3 pi over 2. Let's take a look and see what we need to do when we're solving a trigonometric equation that contains a multiple angle. All of the examples we looked at so far have just contained a singular x, but this example here has a 3x, a multiple of x. Let's first solve this simple equation, sine of x equals 1/2. Sine of x equals 1/2 right here at pi over 6, and sine of x equals 1/2 right here at 5 pi over 6. Let's mark these places on the unit circle. Sine is 1/2 right here, and sine is 1/2 right here. When solving sine of x equals 1/2, I indicated that occurs at x equals pi over 6 and 5 pi over 6. When solving sine of 3x equals 1/2, I'm going to indicate that 3x could equal pi over 6 or 5 pi over 6. Or maybe I'll write it like this: 3x equals pi over 6 or 3x equals 5 pi over 6. Of course, over here, I'm finished solving for x. I know what x equals. Here I'm not finished. To solve for x, I need to divide each side by 3. And the way you divide a fraction by 3, or the way you divide a fraction by 3 over 1, is to multiply by the reciprocal. We need to multiply pi over 6 by 1/3. Pi over 6 times 1/3 is pi over 18. To finish solving this for x, I also need to divide by 3, or multiply by 1/3. If I divide the left side by 3, I must multiply the right side by 1/3. This would be 5 pi over 18. But there's something else we need to do when we're solving a trigonometric equation with a multiple angle. A multiple angle like 3x, this equation will have 3 times as many answers as this will. We've already determined 2 answers. Well, there will be 3 times as many answers. There should actually be 6 correct answers. Spinning around the unit circle 1 time yields 2 correct answers. To get 6 correct answers, I'm going to need to spin around the unit circle 3 times. In my first spin, I picked up pi over 6 and 5 pi over 6. So we already saw that 3x can equal pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and 3x can equal 5 pi over 6, but let's keep spinning. 6 pi over 6, 7 pi over 6, 8, 9, 10, 11, 12. 3x can also equal 13 pi over 6. I'll keep spinning. 14, 15, 16, and 3x can equal 17 pi over 6. 18, 19, 20, 21, 22, 23, 24. 3x can equal 25 pi over 6. 26, 27, 28, and 3x can equal 29 pi over 6. And to finish solving all of these, I need to divide by 3 or multiply by 1/3. This will become 13 pi over 18. This will become 17 pi over 18. This is 25 pi over 18. And this is 29 pi over 18. This equation has 6 correct answers. Now you may be saying, I thought we were supposed to only give the answers between 0 and 2 pi. Why did we spin around the unit circle 3 complete times? Well, notice that this is still smaller than 2 pi. 36 pi over 18 would be 2 pi. This is smaller than 36 pi over 18. This answer is larger than 0. All of these answers are larger than 0, and all of these answers are smaller than 2 pi. I think we should take a look at another example of a trig function that has a multiple angle. The equation tangent of 2x equals negative square root of 3 will have 2 times as many answers as the equation tangent of x equals negative radical 3. So let's first see where tangent of x equals negative radical 3. Well, that occurs right here at 2 pi over 3 and right here at 5 pi over 3. X can equal 2 pi over 3 because tangent of 2 pi over 3 equals negative radical 3. Over here, I'm going to say 2x can equal 2 pi over 3. Because if I replace 2x with 2 pi over 3, if I replace this with 2 pi over 3, tangent of 2 pi over 3 equals negative radical 3. This 2x can also equal 5 pi over 3. To get twice as many answers, we're going to spin around the unit circle 2 complete times, and I'm going to count by pi over 3s. On our first spin, we already picked up 1, 2 pi over 3, 3, 4, and 5 pi over 3, 6. Now let's do our second spin. 7, 8 pi over 3, 9, 10, and 11 pi over 3. 2x can also equal 8 pi over 3 and 11 pi over 3. Now to finish solving these, I'll simply divide each side by 2, which is the same as multiplying times 1 over 2. So here x can equal 2 pi over 6. Here x can equal 5 pi over 6. Here x can equal 8 pi over 6. And finally, x can equal 11 pi over 6. You could reduce this one to pi over 3. You could reduce this one to 4 pi over 3. But I'm fine with 2 pi over 6, 5 pi over 6, 8 pi over 6, and 11 pi over 6. Here I have one more example that's in factored form. I need to see where this factor equals 0, and I need to see where this factor equals 0. I'll isolate the cosine 3x by adding 1 to each side. And there's nothing more I can do here. I can't do any more isolating. I can't divide by 3 to get rid of this 3. To solve this, I'll need to spin around the unit circle 3 times. Over here, I'll add radical 2 to both sides, and I can divide by 2, but there's no more isolating I can do over here. I can't get rid of this 2. To solve this equation, I'm going to spin around the unit circle 2 times. Let's solve this one first. Let's first see where sine is positive radical 2 over 2. Right here, sine is positive radical 2 over 2, and right here, sine is positive radical 2 over 2. Notice that both of these spokes involve pi over 4s. When I spin around twice, I'm going to count by pi over 4s. We'll start at 0. Pi over 4, not 2 pi over 4, 3 pi over 4, not 4 pi over 4 or 5 pi over 4 or 6 pi over 4 or 7 pi over 4 or 8 pi over 4. Let's do our second spin. 9 pi over 4, not 10 pi over 4, but 11 pi over 4. Now to finish solving for x, we're simply going to divide each side by 2, which is the same as multiplying by 1/2. Here x would equal pi over 8. Here x would equal 3 pi over 8. X could equal 9 pi over 8. And x could equal 11 pi over 8. Now, back to this. To solve this, we need to see where cosine equals positive 1. Well, there's only one place where cosine equals positive 1, and that's right here at 0 pi. So 3x could equal 0 pi. But to obtain all the answers, we must spin around the unit circle 3 times. So we've already indicated 0 pi, and then we have 1 pi. 2 pi would be our next spin. 3 pi, and 4 pi would be our third spin. Now I just need to divide each side by 3 in all of these. So x could equal 0 pi over 3, which is just 0 pi. X could equal 2 pi over 3, and x could equal 4 pi over 3. We have 1, 2, 3, 4, 5, 6, 7 correct answers. To solve cosine 3x, we spin around the circle 3 times, and to solve sine 2x, we spin around the circle 2 times.